Alright, so I wanted to go over these 30, 60, 90 triangles, which I know can be really complicated, and what I wanted to do was do it 3 different ways, so if the first way doesn't make sense, that you can see it a couple of different pieces. So, I have a triangle here, and I'm going to actually solve it, so this is the piece of information that I was given. Okay, so we know it's 30, 60, 90, we know that the hypotenuse is 30 long, and let's see from there we can go. Alright, then the first example, which is the simplest but can be confusing, so don't use it if it doesn't make sense. We have this ratio that happens every time, always for 30, 60, 90. So that's x, that's 2x, and this is x radical 3. We proved that on Friday. So if I'm going to use that rule, I'm just going to actually follow the pattern. So right here, if this is 30, that means these two sides to get from here, we're going to times it by 2. So if I'm going to go backwards and I have the times 2 side, I'm just going to reverse it to get to here. So 30 divided by 2 gives us 15. Okay, so this side right here must be 15 because it has to be twice as large. Alright, now if I keep following the pattern, to start at x and go this direction, I just multiply it by radical 3. So I just take 15 and then multiply it by radical 3. Done. Okay, that way didn't make any sense at all. Let's try a different one. So, instead of thinking about the shapes in terms of how they're related together to each side, we know we have the same ratio. Think about each side being equal to the ratio. So, I know these two are the same sides here, this and this. And so let me just set them equal in an equation. So once I have that equation, I just solve it, and I get x equals 15. Okay. Same thing as we got on the first one when we just followed the pattern. Okay. All right. So now that we have x is 15, we know this side we take whatever x is, and we multiply it by radical 3. This time we don't have an answer already. Okay. So we actually have to use the same rule as we did there, but that should be straightforward enough. We're just going to plug this 15 into this x, and so that's how we get 15 radical 3. Okay. Alright, if either of those ways, not understanding the relationship between or how the sides are equal, let's actually use proportions for the last one. So, what I'm going to do is I'm going to write it smaller this time. 2x, x, and x radical 3 is the relationship. Let's get a similar triangle in its basic form. So I'm just going to plug a 1 in for x, so this is 2, and this is radical 3. These right here, between these two, they're similar. So let's use our similar math that we know from before and set up some ratios. So if these two sides are similar, we've got 30 over 2 equals, let's look for x here, x over 1. Alright, let's solve it. 30 equals 2x, and then we get what we already had before, and x equals 15. Okay. We can do another ratio for the radical 3 side as well. Okay, we'll still use 30 over 2 equals x, which we don't know. Maybe I shouldn't call it an x. I'll call it b. Okay, over radical 3. Okay, let's multiply the two together. 30 radical 3 equals 2b divided by 2 divided by 2. Remember we talked about this before. 30 divided by 2 is 15. Radical 3 equals b. And so this right here would be 15 radical 3. Okay. Again, 3 different methods, 3 different ways. This way will always work and always take the longest, but if that makes sense because of what we already did, use it. This way is kind of a scaffold between, so you do have to do some solving and see the solving, but it will also always work. This way takes the most just reasoning and should always be the fastest, but if you're not sure how that reasoning or you doubt yourself, it's probably better to use one of the other 2 strategies. Alright, make sure you ask me more questions in class.